this lesson, we're going to be looking at multi-step equations, and we're going to throw in some special cases there that you will come across. All right, so let's start with the first example here. Nothing to do on the left-hand side of the equal side, so let's move to the right-hand side, and we see a number that we need to distribute into this quantity. So we just need to take the negative 3, and we're going to multiply it by 6a. I'm going to copy down the left-hand side. So equals negative 18a. Negative times a negative is going to give us a positive 12 here. Great. Okay, now there's a couple of options of what you could do first. I'm going to choose to get all of my variables on the same side. And again, which way do I want to go? Do I want to get them on the left or on the right? I would choose to try to make them all on the side where they're going to be positive. So a little bit of forethought, if I add 18a to both sides, that's going to make them both positive. If I had subtracted 8a, it's fine, but I would have gotten negative a's. And that's fine, but I'm going to keep them positive. So, okay, we have 38 plus 26a equals 12. Okay, great. Now it's a two-step equation that we're used to. So we're going to subtract 38 from both sides. Over here on the left-hand side, we have 26a, and that's going to be equal to negative 26. Oh, how nice is that? So we divide by the coefficient 26, divide by 26, and I ran out of room, but a is going to be equal to negative 1. Great. That is a nice normal case of a multi-step equation. We had to distribute first, that's what's made it a multi-step equation, but it worked out nice. We got a nice clean answer. Okay, let's go check out number 2. So in number 2, nothing to do on the left-hand side. I'm going to copy it down. On the right-hand side, the negative 8 is just going to get brought down. Do not be tricked into thinking we can combine those negative 8 and negative 3. The negative 3 here, remember the sign of the in front goes with it, is connected to this parenthesis here by multiplication. And multiplication has to come first by the order of operations, so that's why we have to distribute. So we're going to take that negative 3, we're going to distribute it, make it a negative 3b and a positive 3. Okay. Still, we're going to work on the right-hand side because we're going to combine like terms. We have a constant negative 8 and a constant 3. I'm going to put the negative 3b first, and negative 8 and positive 3 is negative 5. Great. Let's make sure those don't look the same. Okay. Now, we have variables on both sides, so we need to go ahead and get them all on the same side. Well, I'm going to go ahead and add 3b here and add 3b here, and a weird thing happens. We have no b's left, just negative 5. And over here, we have also negative 5. The b's are gone. And we're left with this statement more than equation that negative 5 is equal to negative 5. Of course it is. So this is a special case. And in this special case, we came up with a true statement at the end after we had simplified. All the variables disappeared, and we got a true statement. Negative 5 is equal to negative 5. So that's true. So that what means is any value that we had tried to plug in for b at the beginning would have worked. No matter what value it is, any value would have worked. So what we will say is the solution to b here is all real numbers. All real numbers that we would have plugged in for b would work. And if you want to simplify your answer here, not simplify it but write it shorter, this is the symbol for all real numbers. So you can write that to mean all real numbers. Great. So that is one of our special cases. Okay, let's go ahead and try example 4 here. All right, so again, left-hand side, nothing to do. Copy that down. Right-hand side, all right, gonna distribute. So we get 3x minus 6. Okay, great. So once again, I'm going to try to get all my variables on one side. So I'm going to subtract 3x, and this time I get negative 5 equals negative 6. Well, again, something odd has happened. All the variables have disappeared, but in this instance, we got a statement that is false. Don't let anyone convince you. Negative 5 is definitely not equal to negative 6, so we got a false conclusion from this, which means that no matter what we had plugged in for x at the beginning this time, no value was ever going to work. So we would say that there is no solution for x. You can write this as the empty set notation, meaning if we looked at all the possible answers, there's nothing in this set. The set of answers, no answer, so that's another symbol for no solution. So here we saw some situations where we get a nice answer, a nice integer, could be a fraction or decimal, but worked out to a number. We saw a situation where if we got a true statement, it meant that they were all real numbers. Any number we plugged in for the variable was going to work. But when we got a false statement, that meant that no matter what value we put in for the variable, no answer was going to work, so we have no solution. It is important that you come to a conclusion that this is part of your answer. You can't just leave it off here. You need to write the concluding statement, all real numbers or no solution for your special case situation.